Greetings, the Astro 30 here yet again, and the Amplifier project is now sitting back up on the desk for a specific reason, which I'll get to in just a moment. I did jinx myself in the last part, or the part before, whenever I was talking about these JST connectors, how I was going to wire the two boards together by not using connectors here, because that's just another point of failure. Well, I was testing this amplifier out over the weekend, and one of these connectors had a dicky joint. That is, that the sound became distorted and then eventually dropped out. When I started poking at wires, the sound came back. So I first took off this VBE multiplier connector, did all them, put them back together, tested it, problem still there. So I ended up having to do this connector as well. All I did was take the connector apart and just squeeze the crimps a little bit tighter with the pliers, and it seems to be fine now. However, that's not the issue. The issue is, when this amplifier is plugged in and turned off, this LED glows. I'll show you. So plug it in, or at least try to plug it in. There we go. And if you look real closely, that LED is glowing. And when we turn it on, it's still glowing. Turn it off, it dims out, but it is still glowing dimly.
Unacceptable.
Next question as to why, because I've never actually experienced this problem before, but I reckon it's that 22 nanofarad X2 rated capacitor down there at the bottom, the yellow thing. I reckon that's now acting as a capacitive dropper, so it's still allowing voltage out into the power supply, to the half-wave rectifier through the capacitor, and out to the LED through the limiting resistor. So what I'm going to do is I'm going to set up a multimeter on the bench, and we're going to actually see how much voltage is coming out of that socket there back into the transformer. Right, multimeter is hooked up. Now please adhere to all electrical safety when doing this sort of thing, because the incoming line, even though the switch is off, the incoming line here to the board is still live. So there's still 240 volt AC running around this board, so be very careful. Now, I'm going to try and get into that connector, which is going to be next to impossible, but I'll do it anyway. Now, according to the meter, it's saying nothing. Oh, wait, there we go. 61.8 volt AC. That is about a third of our line voltage. So yes, that capacitor is acting as a capacitive dropper, so it's either the wrong type of capacitor for this job, it just goes across the switch, or there's a fault with the board. I don't know, I don't think so. So out of interest, I'm going to find out what's coming off the transformer between the two secondaries here. So this is only going to be a short video, I'm not going to go into too much information on this, but I'm just curious as to what the AC voltage is going into it. Well, not very much. We've got about 2.5 volts AC coming off the transformer, which is enough leakage voltage to go through the half-wave rectifier capacitor and out through the diode. So if I switch to DC volts, and I'll just measure what's coming off after the limiting diode, 3.1 volt. Which is enough to make it light. So we have an issue. That means that capacitor is going to have to come out, which is a shame, because I did want the action of the capacitor to actually stop the any pops that might happen because of the arcing across the switch or anything like that. But yeah, it's not going to work like that. So safety first, I'll unplug it. And I'll bust out the soldering iron, take that off, and yeah, inspect it first and then desolder it, I guess. Alright, I've taken it out and I've inspected it. It is a 22 nanofarad as far as I can tell, and there's nothing on the underside of this board like indicating that there might be a bit of resistance there or something. I did isolate the switch by disconnecting it. The problem's still there, so it's definitely this capacitor acting as a... oh, that did actually have a bit of a spark on it. Acting as a capacitive dropper. So I'm going to have to unsolder this. There's no two ways about this. If anyone's got any suggestions of what other type of capacitor can be used here that's suitable for 240 volt operation, 250 volt, because I've never actually had this issue before with putting a capacitor across a main switch like on the terminal block or something. It's always worked fine. It's never had any leakage voltage before. Not that I've seen or noticed. Maybe it's a different type of capacitor, I'm not sure. I mean, I'm going to keep the capacitor because there's nothing wrong with the capacitor. Just got to get it out, there we go. So I think those holes are fine like that, I'm not going to clean them up. Alright, I'm going to put the switchboard back into the case and then test it again. The holes are slightly off on this, but being aluminium back panel, the screw as it's being done up will slowly wear the inside of the hole out a little bit. It's not as tight as it was the first time when I put it in. Okay, I believe that that's tight. That's active. Neutral, and the switch, doesn't matter which way around I put them, and I am going to redo these heat shrinks on the end of the leads here because a little bit is still sticking out too much. I mean, look at that one's got a little bit way too much on it, so I'm just going to redo the heat shrink. It's not a great big issue. Alright, that's all hooked up now. Okay, so I'm going to plug it in. No, I'm not. I'm going to hook up my actual AC to the transformer, might help. Let's pass that down through there. There we go. Now I'm going to plug it in. Nothing. It's dead. Don't know how well you can see that, but you can see that the ring is not glowing. So if I now turn the switch on, now it's glowing. That's how it's supposed to be. Alright, so to end this video I might hook it back over where it was, which was sitting on top of that speaker box, and yeah, just play around with it a bit. Okay, it's back in its little home. I'll turn the power switch point on. Power point on. No glow. Turn this on. There's not much of a pop there now, I noticed, since I fixed that lead. Let's see what happens when I turn it off. Nothing, there's no negligible spike or anything there. Okay. Alright. Let's play with this. I can still hear it at 9 Hz. You probably guys probably can't. Anyway, it's producing 5 Hz. It's not very audible though. So that's going to end this video here. It's a shame because, yeah, that's unusual that, well, it's not unusual. Capacitors do that if they're in series with the active line. They act as capacitive droppers. But it's not really configured as a capacitive dropper, i.e. it doesn't have its bypass resistor across it, but it's still putting out 60 volt AC at the other end, which is just enough for the transformer to output like 3 volt or 2.5, whatever it was. So yeah, I mean, it's not a great issue. It doesn't seem to be producing any pop when you turn the switch off, so there's no spikes there or anything, but it's just kind of a shame now that that is removed from the board and there's no component there. If anyone has any suggestions of what else I could use in place of the capacitor, just to put something in the board, I mean, as I say, it doesn't have to be anything there really. But yeah, leave your comments below, but I've never experienced that before, or I've never noticed it, put it that way. Anyway, that's fixed that little issue. So I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon supporter for as little as $1 a month. Anyway, that's going to be it for this one. It was only just a little update video. The next video on this will be about the preamp. Anyway, this is the Astro 30 saying, see ya, have a great day.